please yell at me if you cannot see your grade or your answers. I tried to make it so that you could see your answers and the correct answers too. So just let me know if that's not working and I will attempt to fix it. Today, after attendance, let's do that. Today's a programming day, so if these computers got restarted, I think that Python got uninstalled. So maybe go back and confirm that it's still there. We're going to open up idle. And if it's not there, please go and reinstall it. Because this is where we will be working today. All right. And then remind me, I have another programming assignment to give you. That will be due in a week. Okay. Let's begin with turtle graphics. That's the title of today's slides. It's going to be really cute. I think you'll enjoy this. We're going to draw pictures with Python. Okay, so eventually we're going to get away from programs that just output text and have you input text, which is going to be cool, I think. And that is pretty much it. So, yeah, before we get there, I just have one slightly larger example to get us back in the swing of Python and to remember all the stuff that we talked about last time we talked about Python. Let me give you this programming example. Let's make a program that takes input, requires us to convert those inputs from strings as they are always to numbers so that we can use number operations, and then we'll output some cool idea. Okay, so how about we ask the user for two numbers, and then we're going to compute the first number to the power of the second number. Okay, so that is my fancy program that we're going to write. And remember, the to the power of operator in Python is the 2 stars. It's like 2 star star 3, that's 2 to the power of 3. So that's 8. Okay, so that we're eventually going to be using that. And so the idea is we need two numbers like num1 and num2. We need to make room for them. We need to make variables for them, I would say. So we're going to get those from the user so we can do the star star on them. Okay, and this might seem like we're regressing, right? We're going back and not making the fanciest of programs like we were making in Scratch. Those were a bit more complicated, weren't they? So this is where I tell you that because we have to learn Python and there's a different way of doing things, our programs are going to be slightly simpler for now. Don't worry, we're going to get back to Pong by the end of the class, but it's going to take a little bit for us to get up there. So I guess in general, I would like to say that it takes more code on average to write the equivalent Python program compared to a Scratch program. Okay, that's all. Scratch is made to be very, very easy to make your ideas come alive. So you were lucky learning that language first. But that's okay. Python is cool too. It is a bit lower level, we say. You have to do more work to do the same concept, to achieve the same result. It's a lower level language than Scratch. And there are even lower level languages, so don't worry. This is the highest lower level language I could start you with. We're ready for it. And yeah, so let's get into how do we make this program. We need to get two inputs from the user, so I need to use that input function. Do we remember that? You say input, and then you give a little prompt with strings, and you can be like, enter the first number, and then you give a little space, usually, because the user is going to be allowed to type on the next line, or on the same line right after these characters are finished. And then input, remember, gives back whatever the user typed to us. So we're going to get a string back usually. Let me show you input on the REPL. We can do that. If I say input, enter the first number. It's kind of silly, but it works on the REPL. It's going to run this code and then give back. It's going to print out the answer that it gave back. So enter. And so now it's running the input function. It's like, all right, enter the first number, 42. And then when I press enter, input is going to take that input and give it back. And so this is the result of the input function call, we say, and it was the string 42. Do you remember that? The difference between strings and numbers, strings and ints. What's the type of quote 42 quote as a stir. We don't like those if we want to do math stuff, right? Because 42 times 2 was 4242. That is not what we wanted. And so, how do we convert a string, which is what this is going to be replaced with, to an integer, let's say, because we're going to be getting integers from the user? What do I use? What's the magic word? Do we remember? How do I turn 42 into an integer? The string 42. Yeah, it's just int. Okay, I hope that's coming back to us. So if you wrap this around any string that is itself a number, it will convert it to the equivalent number, and then you can do math stuff with it. So I can say int 42, so it converts it, it'll be replaced with that, and then I can multiply it by 2, and it really is the math 84, right? It does the real work. This is another int that it gives back as the result. So remember this difference between multiplying strings and multiplying actual numbers. So you have to do some conversion between types to get what we want. Any questions about that? Is it coming back to us? That's an important concept. So if I want the integer form of whatever the user typed to us, I can just wrap int around this. Think of this like another function that converts to an integer. Okay? And so this whole thing now will be the number form of whatever the user typed to us. And I can store that away in a variable. I can say num1 equals whatever this big long result is, whatever number I get back from asking the user with this very nice prompt. Okay? So this will be like the first line of our program. Does that make enough sense? Do yell at me as often as you would like. This is nitty-gritty programming stuff, and I want to make sure we're all on the same page. So I'm going to make a new file, and I don't know, let's just call it power, I guess, to the power of some nice name. Let's make a good folder for it. So on my desktop, this one. Let's see, what lecture are we? We are lecture 14. And I don't know, I'll call it POW for power. Why not? So, are we ready to write this program? So we need to get, let's plan it out. Let's plan it out with comments. We need to get the first number from the user. Save it away. Then we need to get the second number from the user. Save it away. And then we need to calculate the first number to the power of the second number. And print the result. Because in Python, outside of REPL land, the REPL always prints it back to you, the answer. But if you actually want text to be displayed in a real program, you have to say print. You have to call the print function. And so here is the 3 steps of our program, right? And if we just write underneath these the actual implementation, it should go well. So let's get the first number from the user. So num1, I'm going to store into the num1 variable the result of asking for input. Enter the first number, a little space for room, and then this is only going to be a string, so I need to convert that result to an int. Okay? And so this gets the first number, stores it into num1. This will get the second number, store it into num2. Very quick change. And then all I need to do to display the result is print it out and calculate that result. So num1, whatever that is, to the power of num2. And that's our program. Let's make this other window a little bit smaller too. Let's try running this. Go to the run menu, run module, and it's like, okay, I'm on this line. Enter the first num. 2, hit enter. It got it, stored it into num1. Enter the second number. All right. How about 3? Hit enter. It got it. It stored it into num2. And then I took whatever num1 was and num2 was, and I took num1 to the power of num2 and printed that result out. So I got 8. Okay? And you could be fancier. You could be like, the result is, comma, because every time you separate things in the print function, it will make a space for you automatically. So maybe you want it to be a bit nicer in the output there. So, I don't know, 3 to the power of 4 is apparently 81, and now it says the result is 81. Okay? So that's a nice 3-line program that does a cool thing. Any questions about it? Do you understand all the steps that are taking place? What needs to happen first? How all the data is moving around? Speak now or forever hold your peace, because it's turtle time after this. All right, so we are now ready to talk about turtles for the rest of the day. I'm excited. So this is a fun library. You can look it up on the documentation page. You can just search for Python turtle. Totally works. You go to the first link. It's called Turtle Graphics. And so we get to make cool looking things like this. This is an example of one fancy artwork, piece of artwork that we could make with the turtle library. It is a library. We're going to import it. It's called Turtle. And it's going to let us draw stuff. All right, and here's all the options. Here's all the stuff you can do. Let me try and give you some information and some background about turtles. Okay? So here's the idea. There's a turtle. I'm not sure, I'm not naming names, but this is a turtle. He exists. And somehow his tail got dipped into ink. There was some spill happened somewhere, but this turtle's tail has been dipped in ink somehow. And he is not a wild turtle. He's a trained turtle. And he is allowed to respond to our commands. He knows how to go forward, how to move around. So we can tell him programmatically what to do. And as we move this turtle, he will draw lines, right? He'll draw from wherever he was coming from. He could even draw dotted lines. We can pick him up, ask him to pick his tail up, put his tail back down onto the page, things like that. So he can move wherever we want him to move. And we can tell him when to make marks. So if we ask him to put his tail down, he starts making marks. And if we ask him to pick his tail up, he won't make any marks. And so we could draw dashed things, whatever you'd like to draw. Okay? So that's why it's called the Turtle Library. It is a piece of one of the earlier programming languages called Logo, which was designed to teach people how to program, which is cool to think about. But you don't need to look any of that up to learn it. I am going to teach you Python's version of the Turtle Library. So, yeah, let's use the Turtle Library. Are you ready? So for the first example, the simplest example, I would like to use the Turtle Library to just draw a square. Okay, we're going to use that turtle, make him walk around in a special way, and he will draw a square for us. Okay, so let me bring up a simple program with the Turtle Library so that we can see what happens. I'll make a new file. I don't need this open anymore. I can say import turtle. That imports the Turtle Library and allows us to use all the turtle dot stuff. And I'll call this square.py. And it's possible that if I run this, it won't do anything at all. Yeah, I need to actually tell the turtle to do something for it to actually show up on the screen. But the idea is the turtle, once the program begins and there's actually code, a window will open up. That is the drawing board. And then the turtle begins his life in the center of that board. And he's facing east. Okay, so he's like facing in that direction. And there's a coordinate system going on. Like he starts at 0, 0 as far as his coordinate system is concerned. So the turtle starts at 0, 0, and he's facing to the right, or east, as far as the library is concerned. And then we can ask him to move around, okay? Remember that we are using a library, which means that we are going to have to use a dot all of the time. Every time we want to use a turtle feature, a turtle library feature, we're going to say turtle dot forward, turtle dot left, turtle dot go to, things like that. Because you always add that dot before the library function, just to say where I'm taking this function from, right? So yeah, essentially the dot, kind of, I want you to read that as apostrophe S. If you go any farther in programming, that will be a useful thing to understand. So it's like turtle's position. It's like the library functions belong to the turtle in a sense. And that is kind of true. So if we ask the turtle, hey, where are you right now? He's allowed to say what his position is. We can use that function call, for example. Turtle.position gives back the turtle's coordinates. So you can set his position. You can also get it. Turtle.position, or pause for short. So here are two functions that we could call, and let's print out the answer just to prove that the turtle begins his life at 0, 0. So let's print whatever the result of this position function gives back. Okay, so I'm going to run this. And yay, there's my turtle. Look at him. He is just an arrow right now, and he is facing to the right. And we asked him for his position, and it is 0, 0. So he starts out right in the middle of the screen, facing to the right, or east. Okay, so that is our first turtle function call. And it's no fun when the turtle is just an arrow. That's silly. The turtle should be shaped as a turtle, of course. We can fix that. Let's see, move turtle state. Drawing state, appearance, shape, yeah. So you can say turtle.shape and give an argument, that's the term, right, for things that go between parentheses. You can give an argument that is a string of, here are all of your options, arrow, turtle, circle, square, triangle, or classic. We're going to use turtle. Cool, huh? So let's make the turtle an actual turtle. So turtle.shape, please become a turtle. Save, run with F5. That's much better, right? I think we can all agree. And he's facing to the right still. His position is 0, 0. We haven't moved him at all. Okay? I think we're now ready for the square. So here is how you control your turtle. You can say, based on your current direction, Mr. Turtle, please move forward. And that is turtle.forward, or FD for short. He can also move backward, and he can turn left and right. All right? Turning left, for example, takes an angle. So you can have him turn 90 degrees to the left, 90 degrees to the right, 45 degrees to the left, things like that. Okay? So some combination of turtle.forward, turtle.left, turtle.right is going to give us what we want. So let's draw a, 100 by 100 square. So here's the kind of thing that I'd like to draw with the turtle. A square that looks like this, and let's, just to make it easy on ourselves, let's have the bottom the bottom left be 0, 0, where the turtle begins. And so he begins facing this way. If we ask the turtle to move forward in that direction, he will draw the bottom line of the square. And he will move to 100, 0. And then if we want him to draw this line next, we have to move him up, right? We have to turn him to the left and make him go forward. But let's draw this bottommost line first. Okay? Let's do that. So the turtle is starting out at 0, 0, facing right. We want him to go 100 units in that direction. So go forward 100 units. That's all we need to do. Turtle.forward 100. And that will have him move. By default, his tail starts down, so he will make marks on the page. And by default, the color that he draws with is black. So if I run this, in addition to printing out his location, he just drew a line. Look at him. Isn't this the cutest thing? So here's the turtle. He drew the bottom line of that square. And now we would like him to face up because then he could draw the top part, or the right side of this square, right? So if we made him go forward, he's still facing that way. So he would go forward in that direction. We don't want that. We want him to face this way. So we need to turn him, just like that. So we want him to turn to the left, right? Because that's where, relative to his current position. Turn to the left, please, by 90 degrees, right? Turn to the left by 90 degrees. So turtle.left 90 is all we need here. We turn left 90 degrees. So turtle.left 90. And then if I run this, he won't draw the line yet, but do you see now that he is facing up? That was 90 degrees to the left of the way that he used to be facing. Okay? So we can just give him commands like this and eventually draw our square. Now that he's in the right orientation, if he goes forward 100 again, he will draw the right side of that square. F5 to run. Sorry, it's hard to keep the program and the slides and all this in view at once, but I think we can understand what's going on. Yeah? And so now what should I do next? Like what do we think needs to happen to continue the square? What should be the next thing I do? Yeah, this is a process that could continue to be repeated because if I just do the same thing over again, he will draw the next line another 90 degrees offset. So we just need him to turn again. We need him to face west now, which involves turning 90 degrees to the left again, right? Turning 90 degrees to the left and then going forward 100. That will draw the top of the square. So there's some repetition going on here. These are regular polygons. That kind of has repetition in the name. So then I have the top part. And what do I have to do to complete the square? It's again, turn left by 90 degrees, Mr. Turtle, and then go forward 100 units. Yes? One last time. And this will complete the square. Whee! There he goes. We did it. And all of these coordinates are not too bad, right? This was 100, 100. We didn't really care, but this was 100, 100. This was 0, 100. That all makes sense, right? Oops. So, yeah. Code, drawing. Any questions about it? And the turtle finishes facing downwards because that was the last orientation we had him in. All right. If you don't like how slow the turtle is drawing things, you can make him draw things faster. You can use turtle.speed for that. That is defined in the documentation up here. Turtle.speed, and it could either take numbers or strings, because why not? So you can set the turtle speed to be fastest, and then he'll go super fast. Or just the number fast, or the number 10, or the word fast. Let's make the turtle fast. Why not? We'll do that before he ever starts drawing. Turtle.speed fast. And now maybe he'll draw a bit faster. Yeah, that was super fast. Crazy. So that's something you can do. What else? So, let's see here. Yeah, I think that's where I want to stop to give you an example or time to play around. So I've just shown you how to draw a single square. I'm going to share this code with you, I guess, on Discord or something. I'll keep it up, or maybe you've already typed it. What I'd like you to do in peer instruction groups, I'll give you a few minutes to try this, is I would like you to draw a second square, okay? Of a different size maybe, some distance away from the first one, but give yourself some practice moving the turtle around, drawing new things with him, and that'll be that. So let me give you this code, and then I'll talk about set heading. because that could be helpful here. Let's open up Discord, I guess. And while it's opening, if you say turtle.set heading and you give a certain number of degrees, the turtle always goes to that direction. Heading is the same as direction. So if you want the turtle to face to the right, degrees is 0. If you want the turtle to face up, that's 0 degrees. If you want the turtle to face up, you set his heading to be 90 degrees. If you want him to face to the left, that's 180 degrees. If you want him to face downwards, that's 270 degrees. Okay, that's a heading. Same as a direction. That might be helpful, depending on where you want to put that second square. Good old Discord taking forever. Question, yeah? Oh yeah, I'll come and help you once I give this code out to everyone. No worries, we'll get it working. Oh, let's find it. So here we are, and here is my code for the square. All right, now that you have it, go be free and draw a second square somewhere. Maybe like a tiny one down there, a giant one up there. You could have a square surrounding your initial square, whatever you like. So take a few minutes to play around. Draw multiple squares if you'd like. Let's get that error fixed. You're running into exactly what I talked about. You name the file called turtle.py, and that messes up the import system. Find wherever you say that. This is our path that got crazy cool later. When you say import, it's really looking for a file called turtle.py. Or math, secretly for a file called math.py. When you have a file named that already, anything but your Oh yeah, it just doesn't do anything until you say the first turtle operation. Say like turtle.4, and that'll bring up the drawing. 3 more minutes. Why not? Play around. Draw other things than squares. You can fix, if you're getting a line in between your squares, see if you can fix that. There's a documentation function for that. And yeah, for posterity's sake, never name a file turtle.py or math.py or anything like that, because then you can't import the library anymore. All right, that was my timer. Are there any questions about what we just tried? You make something cool. Let me quickly draw a second square. Let's see, so we had this. Let me make a square to the left of this one. And so if I want to make one to the left, I can set the turtle's heading. I could either turn him to the right now by 90. There's also a right in addition to left. Or I could set his heading. I could say turtle.set heading. And it's always relative to east. It's like normal math coordinate systems. So change your heading to 180. That will face west. So this is second square. Let's face west, and that will make this happen. Go for it. Now he's in the right direction. Let's move him over a little bit. I don't know. Go over 200. So now he's way over there, and let's draw a tiny little square of like size 50. So turtle dot forward 50, turtle dot left 90, and I want to do this 1, 2, 3, 4 times, and I don't have to change his orientation the last time. That'll be a square. Oh, oops. I spelled forward wrong every time. There you go. And so there's a second square. One thing that is unfortunate is right now there's a line between those squares. Did we figure out how to get rid of that line? How do we ask the turtle to pick his tail up? Did we find that function anywhere? There you go. Here it is. Drawing state. You have pen down, or PD, or down, or pen up, PU, or up. I don't know, let's just say up. And so when we move the turtle from the big square to the smaller square, like from here to here, that was that 200. Move by 200, please. And so before this happens, if we just ask the turtle to pick his tail up, stop making marks, then he'll be in the right spot when he's ready to draw. But if I leave it like this, right, he's never going to draw that second square, so we have to ask him to put his tail down when we want him to actually draw again. Turtle dot down. Start making marks again. Please. Okay, so that will make you a second square, and that's how you can do it without a line in between. Any questions about that? All right, so that's my square example. Let's do a triangle now. Let's do an equilateral triangle. And we have to figure out what the angles are for an equilateral triangle, right? So let's start it again at like 0, 0 or something. And then we can start with the bottom, that's fine. And how big should this equilateral triangle be? Like maybe let's make every side 200. That's fine. So these are all 200, 200, 200. That's all well and good. What's the angle in between for an equilateral triangle? Because these all need to be equal, right? It's an equilateral triangle, and then all these sides also need to all be equal. So these are all 200. Do we remember what this angle is? They have to be equal, and a triangle has 180 degrees in each side. It better be 60, yeah? So this is a 60-degree angle everywhere. So that's essentially the answer. So let's get started here, and let's start the turtle here at 0, 0. Okay? Size 200 equilateral triangle. So I'll copy and paste the first bit of all this, because it's essentially the same. New file. I'll call this triangle.py. And here's what we need to do. We need to have the turtle, if we want to draw the bottom line first, we'll just have him go forward because he faces right initially. Turtle.forward by 200 this time. That's a size 200 bottom half. Every face of that triangle is 200 units. And then we need to move the turtle to make this 60-degree angle. And you might be thinking that, oh, that just means turtle.left by 60. And then I can go forward again by 200. But something is wrong with that logic. Let me show you that. Oh, that was not the right angle. So it wasn't left by 60, and it sure isn't right by 60 either. Let's figure out what the correct angle should have been. Okay? I am forcing you to remember geometry now. So the turtle was facing this way. We want him to now be facing that way. And so we need him to move that direction to the left, which is everything, like this is 60, this is 180 minus 60, right? 180 degrees minus 60 degrees. You never thought you'd have to use geometry ever again, did you? That is the angle that we want to turn by, whatever that is. And you can calculate that and be like, okay, left 120, or you can let Python do the work. 180 minus 60, right? Not a problem. And that will correctly draw the triangle, and then it's all a pattern from there. Again, you want to do that same amount of turning, right? Because the turtle was facing in this direction. we want him to then be facing that way. So we turn him to the left, another 180 minus 60. Just like for the square. And that, my friends, will give us an equilateral triangle of length 200. So here's the code. Here's the drawing. Any questions about that? You can draw any regular polygon now. You know the tricks. Maybe try drawing like a pentagon or a hexagon after class. So, are we ready for a harder problem? Okay, and then that's it. Then you can start on your assignment early. So what I'd like to do, which is going to come up in your next assignment, let's draw my initials. You will draw yours in a future assignment, okay? I think it's the one I'm about to release. So my initials are LN, and let's draw that. Whee! This is the kind of thing that we want to create, okay? L, N, this is my best drawing of all of this. Trying to be as careful as possible because these are supposed to be straight lines. And let's pick some sizes. Let's say that the height of these initials are 200, and let's say that the width of this L is 125. These are just numbers that I picked before that worked. And let's make some space in between the L and the N. Let's not start drawing the N right there or something like some sort of team logo. Let's make some space there, and let's have that be like, I don't know, 40 units. This is not drawn to scale. And then the N can also be 125 units wide. Okay? That is the goal. So, yeah, that's what I want to draw on the screen. And let's see if we can make that happen. Are we ready? So, I'm going to show you the hard way right now. And in the future lecture, I think the next one, I'll show you about turtle.goto. But let's do the hard way first. So, I guess the question is, where do we want to start drawing this? We can start drawing it at 0, 0, but that's kind of weird, right? To have an L start right there. Maybe we would like the L to start a bit to the left. So let's see if we can make that happen. And I'll call this initials.pi. So I would like the turtle to start not in the middle right now because I want to draw my initials and have it take up more space. So let's make the turtle begin back here somewhere. So a very easy way to do that is to say turtle.backward. He doesn't have to go forward the whole time. So in addition to forward, there is backward. We can move the turtle backward by like 200 or something so that he's more to the left. So let's try like 250 or something like that. That's a good starting point. That's at least on the edge there. But I don't want this line, so let's move the turtle up. Have him pick his tail up before he goes backward. And then he won't make that mark. So now he's sitting there, facing to the right, all is well. Okay? So that is my turtle. Maybe I want it to start, like, let's start the L up at the top. That might make it the easiest, right? Let's go back to the slides for that. Let's start the turtle up here. And that will begin our L, right? We want to first move then down and then to the right. So let's get the turtle up now. Let's move him up there while his tail is still picked up. Close all these extra ones that I keep running into. So if he right now is there, we need to turn him to the left by 90. And let's move him up, I don't know, 100? Forward 100. Just getting him into a nice spot. And that seems good, right? I can start drawing my L in that from there. Seems fine to me. So now we're ready. We're ready to actually start drawing. We can pick the turtle's tail down, right? Let's say, please start making marks. And because I want him to start at the upper part of that L, I want him initially facing downwards. So there's two ways to do it. I can either have him turn around 180, or I could set his heading. The heading is always relative to east, how many degrees away from that. So it would be heading 90, 180, 270. I want him to face downwards, so that could work. Turtle.set heading 270. Face, I guess, south, right? Yay, so now he's ready. He is ready to draw that first bit of the L. Let's do it. So I'm checking my notes on my other computer. It's 200 tall by 125 wide. So let's go turtle.forward, 200, and then we need to turn him to the left by 90 and go forward 125, given his current orientation. So turn left by, yeah, it is left 90, and then turtle.forward by 125. Okay. Yay, so there's the L. Any questions up until this point? Did everything that I just did make sense? All right. So now we need some space in between the L and the N. So we need 40 space. Turtle's already in the right direction. So we can just say turtle.forward 40, but that's not good enough, right? Because it's going to make a mark. We got to pick the turtle up before we go that far. Okay? So this bit right here was the L. This bit right here will be the space between L and N. So turtle up. And then we need to put the turtle back down after we've got him in position again, so that he can make future marks. All right, so now we have the turtle right there, ready to go, and now we can have him draw the N. So the first thing that needs to happen is he needs to be faced upwards, right? Because we want to draw, we're sitting right here, we got to go up by 200. So that's not too bad. That will be turtle left 90. And then we go turtle.forward by 200, because that's how tall our characters are going to be. And this is where we get into a bit of trouble. Because turtle's facing this way. Let me use a different color now. Turtle's facing this way. We need him to be this way, which means we need this angle, right? We need to know that angle right there. What in the world is it? Question mark degrees. And then also, in addition to that, we need to know this distance right here. What in the world is that too? Some length L. Because we know this is 100, or this is 200 again, that's fine. But again, we need that same angle here. What in the world is that? Boop, boop. Because that needs to happen. And this is where we have to do some math. Okay, so what are we thinking here? What do I have? What do I need? This is, come on, why don't you let me click you? This is 200. Oh, it's happy again. Okay, so that was 200, and this is 125, and I need to know this angle right now. That's the next thing that I need. To remember our trig. This angle, whatever it is, I know the opposite and the adjacent, so I can use tangent. Tangent of question mark is equal to 125 over 200. Let me draw a better 5. And now we can solve for that angle, right? Question mark is equal to the inverse tangent of 125 over 200, whatever that is, okay? This is all part of the math library. So Python math. We have both of those. We have tan and inverse tangents. Tan. There we go. So it's atan, that's the inverse, also called the arctangent, okay? So that is the result, and it's going to be given in radians. Whatever this answer is given back to us by Python when we call this function, it's going to give it back to us in radians. And we need to give to the turtle degrees, right? Turn left by some degree, turn right by some degree. We want him to turn to the right for once by, I guess it's 180 minus this question mark, okay? So a lot of stuff needs to happen right now. So where do I want to draw this? Whatever that question mark is in degrees is this. Angle equals, it is going to be, well, I need the math library, import math. It's going to be math.atan, 125 over 200. And this is in radians right now. I need to make it degrees. There's a conversion function for that. I think it's just called degrees. Yeah, convert from radians to degrees. It's just math.degrees. So take whatever this is, convert it from radians to degrees with math.degrees. Bam. And now I have that angle. And I want to turn the turtle, not by that angle, but by 180 minus that angle. Turn to the right. Does that make enough sense? It's a long process, but that's exactly what we needed to do. So I need to turn, let me try and give you that picture right here. So now we need to turn by turtle.right, 180 minus whatever that angle is. Okay? And that will set us up for the end, and it should look right. Oh yeah, that's the right angle. Perfect. I love it. Okay? So, any questions about how I just found that? He's ready to go. That was fun. Now I need to know this length. And again, well, now I have an angle to work with. I could use more trig, or I could use the Pythagorean theorem, because what is this but a triangle, a right triangle? Bam. So whatever L is, L squared equals 125 squared plus 200 squared, right? And so solving for L, that is going to be just L is equal to the square root of all that. That's how far I need to go forward. L equals, and it's, remember the square root, it's math.sqrt of 125 squared plus 200 squared. That's my length, and that's how far I need to go forward by. Forward by L. Oh man, was that fun. But it worked. And now we're almost home free. We just need to do this thing one more time. Thanks to, I don't know the right geometry term, but this is the same angle, right? And so I want to turn left by 180 minus that angle. I could alternatively set the heading right now to 90. That would also work. Go over here, please. There we go. Turtle dot left by 180 minus that angle. Well, let's pray. That looks like up to me. All right. And then we're going to go forward by, finally, 200 again. Okay? So, that will finally give us my initials. Voila. Are there any questions about what just happened? That took so long to figure out those 8 lines of code, didn't it? But it was worth it, I hope. Very, very promising, fulfilling. So there is a trick to never have to worry about this. Let me show it to you now, and I'll go more in depth on it next time. Instead of scratching your head about angles and things, you could instead, it's the turtle library, sorry, you can say turtle.goto. If you know a coordinate that the turtle should go to, if you can calculate the right coordinate, the turtle will like teleport there and draw a line from wherever he is to that place. So that is a hint if you don't like doing angle stuff. Okay, so try out turtle.goto. Any last questions about this code or these slides before I release your next programming assignment? Very pretty stuff. And remember, I'm giving you all this code, so definitely use it. All right, so if we are happy, let me show you your next programming assignment. I will release it on Canvas. This will be due in a week, so May 13th. All right, so what I'd like you to do is, in addition to writing your initials, do that too. Write your initials and then the last 2 digits of the year that you intend to graduate. So for me, it would have been LN20, because I graduated in 2020 from college. So please do that. Draw your initials and the year that you intend to graduate, and feel free to use GoTo if you don't want to use the fancy angles like I was using. And just, yeah, as usual, give me a video of you writing that program, or not writing it, showing me the running program and showing me your code and showing me that you understood it. Yeah, just as usual. And so that is your programming assignment for everyone who has not programmed before. If you have programmed before, from now on, I want you to learn Python too. So you get to do the same assignment, but please try and go above and beyond what I was asking of everyone else, because you know a bit more, okay? There are fancier turtle library functions that you can look into. So that is your next assignment due in a week. Any questions about it? All right. So yeah, take the rest of the time to get a good head start on that and ask me questions. That is all I have for you.